Hello everyone, it's Amber Salibio, and I present to you my statistics project. The article I chose was The Ultimate Halloween Candy Power Ranking by Walt Hickey. The purpose of this article was to determine what the most popular Halloween candy is and what factors contributed into making a candy more popular compared to a different candy. The methods used to determine the most popular candy was conducting a survey that asked people what fun-sized candy they preferred when compared to other various candy. Basically, like they would put two candies side by side, such as Hershey's and Reese's, and the people would choose which one they preferred. Then it would generate another matchup between two different candies, and they would continue choosing until the survey got enough data. And from their survey, 8,371 IP addresses voted on about 269,000 randomly generated matchups, with an average of 32 and a median of 11 matchups for each IP address. And these were the results of what the most popular candy was. And it was actually Reese's Peanut Butter Cup. And second place was still a variation of a Reese's candy. There are like 80 entries in total, but only 25 fit in this slide. Sorry. Now, what methods make a candy desirable? Oh, sorry, I meant the methods used to determine what makes a candy desirable was calculating multiple regressions, and it was based on several factors, such as whether the candy contained chocolate, if it contained nuts, if the candy was fruity, if it had caramel, if it was a hard candy, and etc. The factor that they did not use was sugar content and the price, because they determined that those factors had no link to the popularity of the candy. Or, yeah. And these were the results of what makes a candy desirable. And these two tables are saying the same thing, with the lower table being the easier one to understand. And it's saying that if a candy contained chocolate, its win percentage would rise by 20%. If a candy contained fruit, that candy's that candy's win percentage would raise by 10%, and so on and so forth. And so like if you want like an ultimate Halloween candy, I guess you could add up different kinds of candy types to see which generated the most win percentage points, but that is not what I'm going to do. The new use of data, or the question that I'm asking is there a correlation between the percentile of sugar in each chocolate and the unit price percentile of each chocolate at a 0.05 significance level? And what I did to figure this out, sorry. The descriptive statistics was n equals 50. There were like 50 candies from the data, with an R value of 0.3961, and with an average of the unit price percentile to be 0.4442. Now, explaining the methods, or how I figured this out, was by using a t-test, with the null hypothesis being rho equals 0, and the alternative hypothesis being rho does not equal 0. I calculated that the t-value was 2.989, with the degrees of freedom being 48, and the p-value being 0.004403. And from those values, I concluded, or I rejected the null hypothesis. And it's basically saying, or these results basically say, that at the 0.05 level of significance, there is enough evidence to suggest that there is a correlation between the percentile of sugar in each chocolate and the unit price percentile of each chocolate. However, yes, that's very good and all, but if we go back to the descriptive statistics, R equals 0.3961. And even though, yes, there is a correlation, it's not a very strong correlation. It's more weak because R is not close to 1. And you can see this here in this scatter plot, that there is this line of best fit here. or the least squared line, and you can, from this graph, you can see, from this scatter plot, you can see that it is a weak positive correlation between the percent of sugar in each candy and the unit price percentile of each candy. And that is my statistics project. Thank you for listening to me.